Okay, guys, today we're going to start lesson 5, and we're going to be talking about inequalities. This lines up with section 5 in your textbook, and your I can statement or learning objective is I can write and solve inequalities. So as usual, you should have your notebook with you ready to go. You should be taking these notes as we go. Feel free to pause the video or rewind whenever you need to get the notes down. And remember, I am going a little bit faster in the videos, but I won't go this fast in person most of the time. Okay, I will wait on you and pace it how you need. First thing I need you to write down are the inequality symbols. We have 4 of them. You should be able to identify them just by looking. You shouldn't have to think about the alligator mouth or Pac-Man mouth, whatever. You have to know the names when you look at the symbols. So first we have greater than. Okay, another way you can say that in maybe a word problem would be more than. Next is less than. Then we have greater than or equal to. In a word problem or phrase, you might see the term at least. That means the minimum, okay? So you will at least have a certain amount. So you could have more or equal to. Then we have less than or equal to. In a word problem, you might see at most or no more than. That means that this is your maximum. You can have less or equal, but no greater than or no more than. Okay, take just a second. Make sure you get all of those written down. Next, we're going to talk about writing inequalities. We're going to write them before we solve them. Just something to remember. If you see less than used as subtraction, okay, not the inequality less than, but less than as subtraction means you have to reverse the order. Okay, so you flip things around. Okay, here's our first example. The sum of a number and 4 is greater than 8. So this is like writing an equation or an expression. We're just going to read the statement, and we're going to pick out the pieces to create an equation, or in this case, an inequality. So the sum means addition, and we're adding some number and 4. So let's say our number is x, and we're adding 4, and it says this sum is greater than 8. So we look for the greater than symbol. There it is, and it's greater than 8. So that is our answer. Okay, now you could rearrange that. You could have 4 plus x is greater than 8. You could even turn the whole thing around if you wanted to, but this is probably the easiest. Okay, I'm going to give you a couple more examples that I want you to try on your own, and then we'll check them together. Okay, here are 3 more examples. You have numbers 2, 3, and 4. I want you to take just a second, write those examples down, and give them a try. Okay, hopefully you've had a chance to try these on your own, and let's check your answers and see what you get. So product means multiplication. So the product of 7 and q, that means we're going to multiply 7 and q, and is at most 49. So that means it can be less than 49, it can be equal to 49, but no more. So that's less than or equal to 49. Okay. Number 3, 12 less than a number is greater than or equal to 50. So 12 less than a number. In this case, less than is referring to subtraction, so we have to reverse that order. So we have a number, I'm going to say n. You can use x, a, b, whatever you want to. Less than is subtraction, and we're subtracting 12. Now, this is greater than or equal to 50. So greater than or equal to 50. I'm not sure what I was about to write there, but that should be 50. Okay? And then last, I will make at least $300 next week. So I'm not sure how much I'm going to make, so I'm going to pick a variable. I'm going to say M, because that's what I'm making. So I'm going to make at least. So at least means the minimum I'm going to get is 300. I could get exactly 300, or I could get more than 300. So that's going to be greater than or equal to $300. Okay, so that's very, very similar to what we did a couple sections ago. If you need to look back in your notes to find the words that we wrote down for addition, subtraction, multiplication, and division, by all means, flip back in your notes and look at those. That's why we wrote them down. That's why we took time to do that, because I knew you would need them later as well. Okay, so you'll have some problems like this in your Math Excel work, but you should be fine. We've done something like this before. You did this back in Algebra 1, and the only thing that's different here are inequality symbols. But as long as you have your notes, you should be good to go. Okay, next we're going to talk about solving inequalities, but before we get started actually solving them, we need to take a few notes. So first, use the same steps and tips as solving equations. Okay, so back in section 4, we wrote down the steps and some tips for solving equations. Use those same ones here. The only difference is when you multiply or divide both sides of the inequality by a negative, you flip the symbol. Okay, so like for example, if you were given this one-step inequality, negative 3x is greater than 6, you would divide both sides by negative 3, okay, and you'd be left with x. That symbol flips, and you're left with a negative 2. Okay, so that's what I mean. Flip the symbol when you multiply or divide by a negative number on both sides. Another little note, after you solve the inequality, it could be in the wrong order. If you turn the whole inequality around, make sure the symbol flips too. So for example, if your answer is 3 is greater than x, you need to turn that around so the variable comes first. So when you turn that whole thing around, it's like a reflection. You just go whoop and turn it over. So 3 is greater than x turns into x is less than 3. The important thing to note here is you watch where the symbol is pointing. So the opening is at 3 and the point is at x. When you turn it around, it has to be that same way. Okay? So multiply or divide by a negative, flip the symbol. And if you have to turn the whole inequality around, flip the symbol. Now let's actually practice solving some inequalities. We'll do a couple examples at a time. I'll walk you through one, and then I'll pause, and you can pause and try some on your own, and then we'll move up. So we're going to start with some two-step inequalities, and then we'll move up to some more multi-step inequalities. We're not going to do as many examples as we did for equations because you've already spent some time with equations. So the only new thing we're adding here is the inequality symbol and maybe flipping things around. Okay, so number 1, we have 6 is greater than 3x minus 3. We're going to solve it just like it's an equation. If you want to, you can draw the line through your inequality symbol, whatever you want to do. So the first thing we're going to do is add 3 to both sides. And we get 9 is greater than 3x. We divide both sides by 3. And we're left with 3 is greater than x. Now, that's not in the right order, so we need to turn everything around, right? We didn't multiply or divide by a negative, but this needs to be in the correct order. So the x comes first. That it's pointing toward the x, so I'm going to keep it that way, and 3. So your answer is x is less than 3. You can check your answers by picking a number that's less than 3, plugging it into the equation, and seeing if it works. So I'm going to say 2. 2 is less than 3. So 3 times 2 is 6. 6 minus 3 is 3. 6 is greater than 3. It works. Okay, so you can check your answers. Now, pause the video. Take just a second. Try examples 2 and 3. And then come back and check your answers with me. Okay, hopefully you've had a chance to try them. On number 2, you should have added 3 and got m over 3 is less than or equal to negative 3. Then you're dividing by 3. Okay, sorry about that. We had an announcement. So we're dividing by 3. So the opposite of that is multiplying by 3. So I'm going to multiply both sides by 3. These will divide out, and we're left with m. Now, I did not multiply or divide both sides by a negative. We did multiply, but those 3's are positive, so we leave the symbol. And we have negative 3 times 3 is negative 9. That is in the correct order, so I'm going to leave it. Okay, so m is less than or equal to negative 9. Now, number 3, we have negative b minus 2 is greater than 8. So we're going to add 2 to both sides, and we get negative b is greater than 10. Now, we can't leave that negative on b. We have to get rid of it. So you can do a couple different things. You can just swap the signs, okay? You can divide by negative 1, whatever works for you. I'll divide by negative 1 because that helps some people. So those negatives divide out, and we're left with b. Now, this time, did we multiply or divide by a negative? Yes, we did. So we flip that symbol around. 10 divided by negative 1 is negative 10. Okay, that is in the correct order, so we can circle, box it, enter it in. Okay, and so the reason that we have to flip that symbol is because it takes care of this sign change. So this 10, do you see how the sign went from here to here? The flipping of the symbol takes that sign change into account. So that's why we have to do that. It has to do with the signs. Okay, here's example number 4. It looks a little bit different. We've added an extra step. We have a number out here in front of the parentheses. So you can actually go about this problem 2 different ways. So I'm going to show you the way that we would traditionally do it. And then I'm going to show you another way that could save you a little bit of time, maybe on the ACT, and you'll get the same answer. Okay, so traditionally, we would distribute the negative 3 and have negative 3p minus 3 is less than or equal to negative 18. Now, I want you to notice we did multiply by a negative number on here, but that negative number was already being multiplied. We just simplified, so we are not flipping the symbol right here. Okay, now it's a 2-step, so we can add 3. We get negative 3p is less than or equal to negative 15. Divide by negative 3. And this time we do, in fact, divide by a negative number. So we flip that symbol and get 5. Okay, so that's a traditional way. Another way we could do it, of negative 3 times the quantity p plus 1 is less than or equal to negative 18. So what I'm going to notice here is that I've got a negative 3 and a negative 18. 3 can go into 18 really easily. So I'm multiplying these two quantities. So I'm going to divide both sides by negative 3. I'm going to get rid of that. So I have p plus 1 is less than or equal to, oh, wait a minute, what do we notice? Did I multiply or divide by a negative? Yeah, I did. So we have to flip that symbol around. So now it's going to be greater than or equal to. Negative 18 divided by negative 3 is a positive 6. Now we have a 1-step, so minus 1. P is greater than or equal to 5. Okay, so we got the exact same answer. Okay, one of them might seem easier to you, one of those ways. It's completely up to you. And this works because negative 3 was the only thing happening to the outside of the parentheses. There's no addition, subtraction, anything like that. It's just negative 3 times this quantity. And we saw that negative 3 can go into negative 18. Okay, so there's a little shortcut, a little tip that could help you save some precious seconds on the ACT maybe. Okay, here's number 5. 3 minus 2 times the quantity n minus 4 is greater than negative 1. I want you to take just a second and try this one and see what you get. Okay, let's check it. We can't do this one the same as we did this one because there's some other stuff outside of the parentheses. Now, there are some different ways you could work this out. You could move the 3 over to the other side and then distribute. You could distribute, then combine like terms, a few different options. I'm going to distribute first just because this messes people up sometimes. We cannot do 3 minus 2 first. Okay, we just can't do it. Negative 2 is being multiplied by the quantity. So multiplication trumps subtraction. So you have to do this multiplication first. It is a negative. You have to carry it along. So negative 2 times n is negative 2n. Negative 2 times negative 4 is positive 8. We can bring down the 3 greater than negative 1. Now, here you can do a couple different things. You combine like terms, then move the constants to the right. You can move the constants to the right, and then combine like terms over there. A few different things. Do what's easiest for you. Okay, I'm going to combine like terms. I have a positive 3 and a positive 8. That gives me a positive 11. I'm going to bring down 2n plus. Okay, now it's a two-step inequality, so I'm going to subtract 11. I get negative 2n is greater than negative 12. Divide by negative 2. And we get n. Do I need to keep or flip that symbol? Flip it because we divided by a negative. Negative 12 divided by negative 2 is positive 6. Okay? Go ahead and try number 6. We have negative 2 times the quantity b plus 1 closed quantity plus 4 is less than 10. See what you get. Okay, now you can check your answer. You should have gotten b is greater than negative 4 because we distribute this negative 2 and get negative 2b minus 2, and then plus 4 is less than 10. Okay, you combine your like terms and get a positive 2. Then you have a nice two-step equation, or inequality, excuse me. Subtract 2, you get 8. Divide both sides by negative 2, you get a negative 4. We had to flip the symbol because we divided both sides by a negative. Okay, here are our next two examples, 7 and 8. If you want to, if you feel pretty confident with solving equations and solving the inequalities, pause the video and give both of these a try. If you want to watch me work through number 7 first and then pause and try number 8, that's fine too. Okay, hopefully you've tried at least one or maybe both of them on your own. Number 7, we do need the distributive property because we have these parentheses. We're going to distribute 3. 3 times 6b is 18b. 3 times negative 1 is negative 3. And then on the other side, we have 18 minus 3b. Okay, we don't have any like terms on the left. We don't have any like terms on the right. So we need to work on getting all the variables together. Now, with inequalities, I try to always get my variable to the left side. And I do that because then my answer will be in the correct order. We will have that variable, symbol, and then number. Okay, so that's what I recommend, but you can do it different if you want, whatever's best for you. Just make sure your final answer is in order. Okay, so I'm going to move 3b to the other side. Notice I'm lining the b's up. I have to combine those together. So 18 plus 3 is 21b. Minus 3 is greater than 18. We have a two-step, so we'll add 3. We have 21b is greater than 21. Divide by 21 on both sides. And we're left with b is greater than 1. That is in the correct order, so we'll leave it. Okay? If you haven't given number 8 a try, you can pause the video and try it now. And let's check our answers. So we have 26 plus m is greater than or equal to. Let's go ahead and do the distributive property here. 5 times negative 6 is negative 30. 5 times 3m is 15m. Okay, and again, I'm going to go ahead and move my m's to the left. Now, that is going to give me a negative m, but it's okay. So I'm going to subtract 15m. Remember, you can do it differently if you choose. So 26 minus 14m is greater than or equal to negative 30. Okay. Now it's a two-step. I'm going to subtract 26. And I get negative 14m is greater than or equal to negative 56. Okay. I'm going to divide both sides by negative 14. And let's get my paper up. We get m. Am I going to keep or flip that symbol? I am going to flip it because we're dividing by a negative. And negative 56 divided by negative 14 is a positive 4. So m is less than or equal to 4. Examples 9 and 10 are both a little bit longer, a little bit more complex. So I want you to give this one a try and see what kind of answer you get. Okay, and let's check your answers. So when you look at this, my first inclination is to distribute the 6's on both sides, but you could also use that little tip that I told you earlier. You have a 6 being multiplied on both sides, so you could divide by 6 on both sides, and that would just leave you with a negative here. And we should still get the same answer regardless. Okay, and I can work it out that way over on the side if you want to see it. But just my first inclination is to distribute, and most of you would probably be on that same mindset with me because you see the parentheses, you want to get rid of them. So we'll do that way first. So negative 6 times 1 is negative 6. Negative 6 times 6x is negative 36x. Is less than 6 times 1 is 6. 6 times negative 5x is negative 30x. Okay? And then we will get our variables together. I'm going to add 30x to both sides. And I get negative 6 is, or minus 6x is less than 6. I'm going to add 6 to both sides. And I get negative 6x is less than 12. We divide by negative 6. We get x is greater than, I almost messed it up, x is greater than negative 2. Because we did divide by a negative, so we have to flip that symbol around. Okay, now, over here on the side, this is what I was talking about. So, if we have negative 6 times the quantity 1 plus 6x is less than 6, 1 minus 5x, then we can divide both sides by 6. Those divide out, and we're left with 1 minus 5x on this side. On the other side, we're left with negative the quantity 1 plus 6x. Okay? So then you can distribute this negative. That gives you negative 1 minus 6x is less than 1 minus 5x. And then that looks very, very similar to this. The only difference is all of these have been divided by 6. Okay, so I can add 5x. I get negative 1 minus x is less than 1. I add 1 to both sides, and I get negative x is less than 2. Divide by negative 1, and that gives me x is greater than negative 2. Okay, so again, exact same answer, two different ways to get it started. Again, if you can see this, that might shave some time off for the ACT, but you don't have to do it that way. That's just an option. Okay, number 10 looks a little wild. There's a lot of stuff going on. So you're going to need the distributive property. You're going to need to combine like terms on each side. You're going to need to get the variables together and then solve. So take just a second, take it one step at a time, and give this problem a try. Okay, hopefully you've had a chance to work it out. Let's see what you got. You can go about this a lot of different ways. I'm going to follow the list of steps that we wrote down for section 4. Okay, and now I know a lot of you are going to do it differently, and that's fine. So I'm going to start with the distributive property. 3 times x is 3x. 3 times negative 4 is negative 12. I have another distributive property. I'm going to distribute this negative. So negative of x is negative x. Negative of negative 4 is positive 4. I'm going to bring down everything on this other side. Now, I'm going to combine like terms. I'm not going to try to move anything until I get everything combined that I can. And if you need to, draw a line down the middle of the inequality symbol. Keep everything in order. All right, so on the left, I've got a 1 and a 1, and that gives me 2. I have an x and 6x, that gives me 7x. So I have 7x plus 2 is greater than. On the other side, I have 3x and negative x, which is 2x. I have negative 12 and positive 4, that's negative 8. Now my problem looks like everything else that we've done. So get our variables to the left. 7x minus 2x is 5x. We have negative 8. Now it's a 2-step. We're going to subtract 2. Get 5x is greater than negative 10. Divide both sides by 5. And we get x is greater than negative 2. Okay? Now, those are all of our examples, but I do want to talk to you about some different solutions that you could get. And you might have a question, just like we did with the equations. One of your questions might say, is this statement always true, sometimes true, or never true? So let's make a little note about that so you know what to look for, okay? So if it's sometimes true, okay, before when we had equations, if you got x equals 5, then that was sometimes true because you had to use the correct number for it to be true. So it was only true if you used a 5, okay? The same kind of thing is true here. If you have x is greater than 3, that's a sometimes true, okay? Because it's true if you use a number greater than 3. We also had never true, and that was when we had numbers like 7 equals 8 or 0 equals 20. That's never true. So the same kind of thing would be here. If you have 3 is greater than 7, is 3 ever greater than 7? No, that doesn't work. That's never true, okay? We also had always true. Whoop, I almost lost a L there. So always true. And that'll be a statement that is always true. So like 0 is less than or equal to 7. That's always true. 0 is always less than or equal to 7. Okay? So when you have a question like this in Math Excel, just think about your answers. If it has a variable in it like that, it's sometimes true. It's never true if it doesn't make sense like this. And it's always true if it is a true statement, like 0 is less than 7. Okay? If you need help with anything, as usual, let me know. Use one of the tools in Math Excel. Send me an email, comment on Google Classroom, whatever you need to do. Have a great day.